All right. Good day, everyone. I hope we are doing fine, and I hope we enjoyed the training we just finished, the understanding quantitative data analysis. All right, in research. So I promise us that we'll actually do this video for us to really deal with the data analysis techniques. Okay, that we have in research, or some of them, not all of them, are we taking this training, and then I will tell us where we can use them. Okay, because most of us, that's a challenge that we are having. When can we use chi-square? When can you use ANOVA? When can you use t-tests, regression, correlation, all these techniques? Okay, I'm not taking us how to analyze. I'm not taking us how to use the software. Okay, you know, all the data analysis techniques, we use software for them. I'm not taking us how to use the software. I'm taking us the understanding of these techniques. So it's when you get your understanding that you now go to the software and apply it. You understand? You cannot go to the software to apply the understanding that you don't have. Do you understand? And that's the purpose of this class. So I will share my screen with us now. Okay, and then we kick off. All right, so let's continue this this aspect. So the first thing that you need to note when you want to determine the data analysis technique you are going to have is the data set that you have. All right, the data set that you have. You have to determine if the data set is categorical or continuous. Okay, if it's categorical or continuous, that's the first thing, your data set. Or let me say the variables in the data set that you want to use for the analysis. Now, what are categorical data? Are data, you can see it is qualitative characteristics. They are nominal data. Okay, people that attend my data analysis class with SPSS, they will understand all this terminology because I talk to them based on it. Okay, as a data analyst, there's some terminology that must be common to you. You understand? They must be common to you. So categorical data are qualitative. They have qualitative characteristics. All right, they are nominal data. They are data that has yes or no. Okay, if it's a categorical, it means it has option. All right, it has option. You understand? You know, by the time you have your questionnaires, we have a lot of questions that has options. So those are categorical data. If you say sex, you either male or female, that is categorical. You understand? And they are qualitative in characteristics. In statistics, they are qualitative. They are not numerical data. Now, continuous data, the second one is quantitative or numerical. Are you following? Is what? Is quantitative or numerical. Okay, because you have to understand the differences between the two before you can say you want to go on in analysis. Are you following me? Before you can say what to go on analysis, you have to understand the differences between the two. Now, I want us to look at this categorical qualitative data. You can see political party. Did your memory improve? Answer yes or no. All these are categorical data. Which gene was expressed? Okay, which gene was expressed? So when you have data set that's in the questionnaire, they are open-ended. They are open-ended, but the answer is qualitative in the sense that to be in sentence. To be in sentence. That is a categorical qualitative data. That you can also classify that as a nominal data. Okay, but I think categorical can stick more with us. Okay, now another one that you need to take note of is the I'm sorry, I'm coming. I'm coming. Okay. So this was what I was looking for. Now, continuous data, you can see heart rate, age, number of bacteria colonies. All right, number of bacteria colonies. All these are continuous data. They are quantitative data. So quantitative are continuous in the sense that they are numbers. If you say the age of a person, all right, the age of a person in the questionnaire, if it is stated in an open-ended question, in the sense that it has to be filled by the person like 18, 19, 20, then that is a continuous data. That's a quantitative data. But once it is categorical in the questionnaire, and it's in a sense that they put options there. Sorry, that was a break. Yeah, sorry, that was a little break that we just had. So now, if you have options in the H sector, it is already categorical. But if it's normally at open-ended questionnaire, it means it is continuous. Majorly, continuous data are data that are numbers. The answers are in numbers, like the cost of something, the record of this thing, okay, the income level of a particular people or a particular person. You understand? Okay, the height of this person. Okay, those are continuous quantitative data. So you have to understand these two types of data for you to say you want to really understand the data analysis techniques. Is your data continuous, quantitative, or is it categorical, qualitative? Or is it qualitative? Is it continuous? Okay, just understand the two. Quantitative and categorical. Qualitative and nominal. They are the same thing. Okay, qualitative is the same as categorical. Continuous is the same as quantitative. Okay, those two like that. Quantitative, okay, quantitative data, it's continuous data. Okay, categorical data is nominal data, and also it is qualitative data. Do you understand the two now? All right, so now the second one that you have to understand is the purpose of the analysis. The purpose of the analysis, you have to understand that. Right, once you understand that, you are one leg away from actually knowing the data analysis techniques that you want to use for your work. You understand? Okay. So now look at it. The purpose of your analysis. Are you doing comparison or you are doing relationship? You can see type of data, categorical, continuous. The next is the purpose. Are you doing comparison or you are doing relationship? Now, comparison deals with sometimes a particular set of data. You are comparing between male or female. Okay. We are comparing two samples that you used. Are you following? Comparison. Okay, you collected a data, you want to compare it against a global data that is online, all right? Or you did an experiment, you want to compare before and after the experiment. Most of the time, during comparison, we use mean comparison. We compare the mean of the data. All right, we compare the mean of the data. People that use comparison the most are people in medical sciences, all right, in health sector, because you do more of experiment. You understand? You compare two samples together. Okay. And that's when we have t-test and ANOVA, okay, and some other tests. When you are dealing with the comparison, okay, you compare the mean of a data set with another data set. So you have to know, what are you actually doing? Are you doing comparison or what? All right, that's one thing you have to note. Now, another thing you have to note is that, are you doing relationship? You know, under comparison, that's where we have significant difference. Under relationship, we have significant relationship. Right? If you are doing relationship, then you are measuring the effect of something against something, like the effect of COVID-19 on Nigeria economy. Are you following? Now, under comparison, you can comparing the economy before and after COVID-19. you can see the difference between this hypothesis, comparing the economy before and after COVID-19. So you collect the data of before COVID-19, collect the data of after COVID-19, and you compare the mix. That's comparing. Relationship is that you want to measure an effect. Effect of this on this, impact of this on this. Okay, now you can say that after you've compared the relationship, after we've compared the differences between economy of COVID-19 and economy after COVID-19, after you've compared it and there is a significant difference, you can now say that the reason for the significant difference is the lockdown. Are you following? It is the lockdown. And then you can ask me, how do you know a significant difference? Is when your p-value is lesser than 0.05. Okay, if you attend my data analysis training, you understand what I'm trying to say. Okay, but that comes in when we are using the software. This is just me creating the understanding. So by the time you are writing your methodology, you can know the tests to fill. I'm going to use the test for this. I'm using ANOVA for this. I'm using chi-square for this. I'm using regression for this, based on this understanding I'm supplying. Are you following? So the purpose of your analysis is either comparison or what? Or relationship. And look at the types of data, is that categorical or continuous. Now, continuous data flows more with relationship. Categorical flows more with comparison. Don't forget that. Continuous flows more with relationship. Categorical flows more with comparison. Okay? All right. So if you know that in your mindset, you are going to use a comparison analysis, it means that you should collect a categorical data. Do you understand? All right. So the next thing I will take us is simple. Let's go. Right. So, okay. So now your data falls around these techniques. Your data analysis falls around these techniques: chi-square family, t-test family, is t-test or ANOVA family. ANOVA falls under these two. Okay, correlation or regression. Are you following? Then you have chi-square. So these are the areas of the test, and all these tests depends on what I just finished taking us. Either your data set is continuous or what? Or categorical. You understand? Quantitative or categorical. Okay, and either you are doing comparison or relationships. Have those two at the back of your mind before you now say you want to select your data analysis technique. So let's go. Now, look at this. When you have a data set, all right, that is comparison and is categorical, you are using chi-square family. You are using chi-square. All right. Purpose: comparison, categorical, chi-square. Okay. Now, so if you are comparing, what are the things that you can actually compare? Okay, we are comparing male. All right, effect of male. I want to talk about a statement. Okay, I want to talk about a statement. Okay, you are looking at the significant differences between a factor that affects sex and also affects marital status. That's categorical. Sex is categorical, marital status is categorical. And you're looking for how the factor affect both of them. Now look at this second one, relationship. When you're looking at when your data is continuous and its other relationship, you are looking at correlation family and regression family. Correlation and what? And regression family. So it should be at the back of your mind. I'm looking at connections. I'm looking at an effect of this on this. and my data set is continuous. All right, my data sets, I'm dealing with I'm dealing with income of the respondent. I'm dealing with household size. All right, I'm dealing with height. I'm dealing with a measurement I took. Then you are looking at continuous. All right, and its relationship, you are looking at correlation. Now, when you now look at a categorical and continuous together, the data set is categorical and it's continuous, and your purpose is comparison. You know, chi-square is the two data sets are what? Categorical. But you're also looking at comparison. That's chi-square. You understand? The first time, once you understand your data set, it is easier for you to pick the data analysis techniques. Very, very easy. So once your data set, you know, I told us in class, when you are dealing with all the data analysis techniques, you have to understand two variables, dependent and independent variable. You understand? But fortunately, when you are dealing with comparison, there's no dependent and independent. You can't, male and female does not depend on each other. They are separate. You're just comparing the two. Are you following? They are separate. You understand? So now, but it should be two data sets. You cannot run an inferential statistics. Do you remember inferential statistics? Descriptive and inferential. We can still remember the two. Inferential statistics are these statistics I'm taking us. Descriptives are where you have frequency, percentage, and some other thing. And I told us when to use all those ones in the last video. All right, when to use them in the last video. Now, these particular data analysis techniques require at least two data sets. At least two data sets. So that's why you are saying that when you have a comparison, your purpose that you want to compare, you collected two sample size. You have an observed data and you have the normal data. That's you comparing. Are you following? So when you now have the data set, one of them is categorical, one of them is continuous. You are using what? T-test. Are you following? You are using what? T-test. Okay. So now look at this now. Chi-square, T-test, correlation. Chi-square is what? Comparison, categorical only for the two data sets. T-test, comparison, categorical, and continuous. Correlation is what? Continuous only relationship. All right. Do we get it now? Good. Okay. Right now, I want to take us this. Okay. Because this will allow me to explain some things to us. Because we have some different types of t-tests. Okay. We have two sample t-tests, two sample peer t-tests, two sample unpaired t-tests. All right. And I told us ANOVA is in that category. Now, look at this. How many samples do you have? How many samples do you have? One sample usually means I'm making a comparison against a historical or global value. You finish collecting your data, and then you want to compare it against a data out there. All right, you use one sample t-test. You do what? You use one sample t-test. Now, two samples. I have two samples. Okay, I have two samples. Traditional control group versus test group in an experiment. Two samples. One sample is normal control group, then the test group. We are comparing one group against the other. All right, we are comparing one group against the other. Then what we use is two sample unpaired tests. Two samples unpaired tests, unpaired t-tests. Please note the difference. That's why I'm giving us these details now. When you have two samples, control and test group, you are comparing one group against the another group. You understand? Remember what I said in the first time. T-test. T-test must be what? All right? Must be what? categorical and what? And continuous. Categorical and continuous. Now, these two samples, when you now have two samples, functional group against test group, comparing one group against the other, then you are dealing with what? Two sample t-test. Now, when you now have one group, that is now you say two samples, two each samples, special samples. One sample, but you tested it twice. Sometimes we call it pre-test and post-test. One sample, you tested it twice. You understand? You tested it first time, you collected your data. The second time you collected your data, but it's still one sample. Then you are using two sampled paired t-tests. The same population, the same sample size. You understand? You give them a test, you mark them, you taught them, and then you give them the test again. Of course, you now want to see the differences in their score. Now, the differences in their score will determine if you taught them well. And that's what you want to look at. Are you following me? That we want to look at. You taught them the first time, you gave them you enter the class, you give them a test on sex education, and you marked it. And then you enter the class, you now taught them on sex education, you now repeat the same test again, you repeated it again, you now marked it. The differences in their score, all right, you are going to use two sampled PET tests because it's to one sample, but you tested it twice. And your testing will determine if what you taught them, if it's relevant or not to the academic success. Are you following? Now, when you now have three samples, that's when you use ANOVA. ANOVA will tell you if there's a differences in one of the samples. Are you following? Are you following me? When you now have more than two samples, that's when you have what? You have ANOVA. Okay? Let's look at this. Now, as we round up, I want us to look at this table very well. Let's look at this table very well. Now, you can see one sample, two samples, two samples special, three samples. All right. One sample proportion, two samples proportion. Okay. This table will summarize everything for you. So it will be easy for you, very, very easy for you to do anything that you want to do. Okay. So I told you when you have one sample categorical, one sample quantitative, then you have what? One sample t-test. Okay, one sample t-test. That is, you have one data set, you are comparing it against one global something. So two same proportions, two samples against one, okay, two same proportions, that's two samples, two sample. Are you following? Now, that is, you can see that two specials, two sample t-test, two sample PET t-test. Now, I just finished explaining to us now. Three or more samples, you have one way ANOVA. You have what? You have one way ANOVA. And then correlation is when you have quantitative throughout, quantitative data set. You can see two samples special, correlation or regression. You see, correlation and regression are very simple. That does not have problem. When you are measuring relationship, that's correlation, and your data must be continuous, must be quantitative. That should not be a problem at all for anybody to choose if your analysis will be correlation or regression. In fact, most people just pick it as random. But most people don't know when to use one way ANOVA or correlation or regression. When we are comparing things, when we are doing comparison, okay, and you have more than three samples, that's when you use ANOVA. When you have two samples and you are comparing things, then you are using t-test. You now have to factor in, are you using one sample t-test? Is it two sample test? Is it two sample PAT test? Is it two sample on PAT test? So you can rewind the video and look at how I explained this to us. You understand? So, all right, thank you, everybody. I will advise you to register for the upcoming data analysis class and also the research class. The research class will combine from how to write chapter 1, chapter 2, chapter 3 of a project. Okay, how do you select objectives? How do you write your hypothesis? Is under your hypothesis, you write all these things. All right, the statement that require all these techniques is you write under your hypothesis. And then you now come and give the data analysis techniques under your methodology. And I told us you cannot be a good data analyst if you don't understand research to some level. Okay, currently now those trainings are going for at a discount. So make sure you register. All right. So thank you, everyone. If you need further clarification, you can chat me up. All right. Thank you. God bless you.